Let's look at another example of how to solve a system of linear equations using a substitution method. Now, I want you to be careful on one of these ideas. That's going to be very helpful as we come on up. So, first of all, what I want to do is solve either equation for a particular variable. Well, you notice right away that one of these equations, neither of the equations, is solved for a particular variable. So what I'm going to do is rewrite the system. And what that means is, well, first of all, which one do you want to solve for? Do you want to solve for this x or that y, which we can, or do you want to solve for this x or that y? We have four options. Well, in this particular case, I hope you realize that maybe solving for this x, that might be the easiest thing to do. Doesn't mean that's what we have to do, but why not? When we have a chance, let's do something that's as easy for us as possible. That's what I think. So bear with me and I'm going to explain what I'm going to do here. See what I did? I did two things. First of all is I took this second line, the second equation, and I rewrote it and solved for x. The other thing I did helps me keep my notes clear. Is I rewrote the entire system again. I didn't change anything in this first line. I did on that second line. But because this is a system, for me, I like to keep it written as an entire system. And I find that to be helpful, especially as some of these systems might get a little bit more complicated. All right, I have our system now. It's the same systems as this, just written a little bit differently. So the second part is substitute. So I'll take 5x minus 4y equals 9. I'm going to substitute my value of x. X equals 2y minus 3. So anywhere I see an x, I can substitute the entire 2y minus 3 in. And now we can just do what's kind of fun, or I hope it's becoming fun for us. Let's solve that and work that through. Solving it down, I received earned. Yeah, sure, why not? A y equals 4. So I know that where the system of where the solution is at, it's going to happen somewhere on the y equals 4 area. So now what we're going to do is go to the next part, part 4, which is back substitute. I'm going to take this solution I got from where I added this line right here, then I'm going to substitute it into this other line, to this other variable right there, or this other equation. So I have x equals 2y minus 3. X equals 2 times 4 minus 3. X equals 8 minus 3. X equals 5. And so I have a solution of solution set of the coordinate pair 5 and 4. And that's the solution to both of these systems. Now notice here when I have this y equals 4, I sometimes get confused. All right, I have all these lines up here. Which one do I substitute it back in? I lose track. Well, the thing we need to remember is we substitute it back into the equation or line that we did not use in this step right here. We used a 5x minus 4y equals 9. That's what led us to get y equals 4. So I don't want to back substitute it into its equation where we got it from. I want to back substitute it into the other equation. And please note, I can substitute it in here or there. Since those are the same equations, I could have done it in that one too, and that would have been perfectly acceptable as well.